solve a numerical which is based on multiple roots of equation. So here we have to show that the roots of the given equation are given by plus or minus I cot r pi by 7, where the value of r is 1, 2, 3. So it means r is equal to 1, so that will give me two roots, plus I cot pi by 7 and minus I cot pi by 7. Similarly, when r is 2, I'll get again two roots, that is plus I cot 2 pi by 7 and minus I cot 2 pi by 7, and so on. So we have to find out these 6 roots. So now guys, the equation which is given is having degree 7. So if the equation having degree 7, then we should get 7 roots. So let's see that if we should get 7 roots, then why are we getting 6 roots in the answer? Where is the 7th root? And we'll get the answer of this question when we'll solve this numerical. So let's start. So to find out the roots, we know this process. The process is, first of all, we have to find out the value of x in general polar form. Then we apply the de Moivre's theorem, and then we substitute different values of k to get the root. So I'll follow the same process. So here x plus 1 raised to 7 is x minus 1 raised to 7. Now first thing is I have to get the value of x as a general polar form, or you might say polar form, then we'll convert it into a general polar form. So for that, I'll take this x minus 1 on left hand side. So this will become this whole raised to 7 equal to 1. Now I'll take 7th root on both sides. So we will get, therefore, x plus 1 upon x minus 1 equal to 1 raised to 1 by 7. Now guys, 1 is in Cartesian form, we have to convert it into polar form. So we know that 1 is represented as cos 0 plus I sin 0 raised to 1 by 7, because cos 0 is 1, sin 0 0, so this term will go and we will get 1. So this is the value of x plus 1 upon x minus 1. Now next is, we will convert this polar form into general polar form, and for that we will add 2k pi in theta. So this will become cos of 2k pi plus I sin 2k pi raised to 1 upon 7. And now guys, we will apply the de Moivre's theorem to this right hand side. So here I'll say, therefore, by x plus 1 upon x minus 1 is equal to cos of 2k pi by 7 plus I sin 2k pi by 7. Now here on the right hand side we have followed all the steps, but on the left hand side we still have a quantity x plus 1 upon x minus 1. So guys, if I want to find out the 7 roots, then we have to substitute different values of k starting from 0. So I can substitute those values on right hand side, but on the left hand side we will get this quantity, but we want to get the roots, hence we should bring x on the left hand side. Now the question is how to bring x on left hand side, and to get that x on the left hand side we are gonna use the process of componendo and dividendo. So guys, for time being I'm considering this 2k pi by 7 as theta, and I will apply the componendo and dividendo on both sides. So here I'll say by componendo and dividendo on left hand side. See what I'm doing. Now I have the value x plus 1, that is the numerator, so I'll add denominator in it, so that is x minus 1. So same process I'll do on the right hand side. So here numerator is cos theta plus I sin theta. So as I said that we are considering this 2k pi by 7 as theta for time being. So here on the LHS we added numerator with denominator. So here numerator is this and denominator is 1. So plus 1. Now here on the left hand side we will subtract denominator from numerator. So this is the numerator minus denominator. So this will become minus x plus 1 and this will become cos theta plus I sin theta minus 1. So same process I am doing on right hand side. Now 1 minus 1 cancel, we will get 2x. X and x cancel, we will get 2. And guys, by cancelling 2, we are straightforward getting x. So which is equal to this value. So I'll rearrange this. That is 1 plus cos theta plus I sin theta. And here from this minus 1 and cos theta, I will take a negative sign outside. So that will become positive 1 minus cos theta and plus I sin theta as it is. So 2 cancel. Now guys, I got x on the left hand side, but on the right hand side I got big term. So now I have to reduce it, and again then I will put theta as 2k pi by 7. So here I will say where theta equal to 2k pi by 7. So I'll simplify it to put theta as 2k pi by 7. So let's start. So 1 plus cos theta will convert it into half angle, which is 2 cos square theta by 2. So this will become, therefore x equal to 2 cos square theta upon 2 plus I. Now sin theta is 2 sin theta by 2 into cos theta by 2. Now in the denominator, 1 minus cos theta is 2 sin square theta by 2, negative sign as it is, and this is again the same formula like this. So this will become now guys, let's take common terms together. So from numerator 2 cos theta by 2 outside, in bracket we will get cos theta upon 2 plus I sin theta upon 2. Similarly, from the denominator we will take 2 sin theta upon 2 common, and here we will get minus sin theta by 2 plus I cos theta by 2. So I can cancel this 2 with 2, and here we will get cot of theta by 2. So cos by sin is cot. Now let's solve this. So now this number, it is in polar form, but guys, don't make mistake in denominator, it is not in polar form, because as per the polar form the real part is cos and the imaginary part is sin, but here the real part is sin, so I have to convert it into cos. So now how to do it? So there are many ways that we can use here the formula of pi by 2, like let's say cos of pi by 2 plus theta by 2, which will give us the angle. This is a one way, and the other is we can take this I common to get the answer. So now I will take this I common from the denominator. So this will become numerator as it is. So cos theta upon 2 plus I sin theta upon 2. From denominator I am taking I common. So this will become cos theta by 2, and this will become minus 1 upon I sin theta upon 2. So to get this value. Now this is in exponential form, it is e raised to I theta by 2. So here I will write down, it is equal to cot theta by 2 e raised to I theta upon 2, and here 1 upon I, we know the property 1 upon I is negative I, so that will become negative negative positive I. So here I will write down I into cos theta by 2 plus I sine theta by 2. So this is due to the property that is 1 upon I is equal to minus I. Now guys, this is also e raised to I theta by 2. So it means I can cancel these two terms. So this I'll take in numerator. So 1 upon I is minus I. So that will become minus I cot of theta by 2. That is the value of x. And now let's resubstitute theta as 2k pi by 7. So x will become minus I cot of 2k pi by 7. 2 cancel. So k pi by 7. And now from here we will put different values of k to get the required roots. So now we will put values of k as 0, 1, 2, 3, 4, 5, 6 and 7. So let's see what do we get. So when we put k as 0, here we will get cot 0. So guys, what is value of cot 0? And it's infinity. So the root of an equation or a finite equation cannot be infinity. So therefore we will neglect that root. So you must be thinking that why did we get the root as infinity? So let me tell you that this was the given equation. So if you expand it on left hand side and right hand side by using, let's say, binomial theorem, then guys, x raised to 7 will be cancelled on both sides and your equation will be a degree 6 equation. It means actually it is a degree 6 equation, therefore we are just getting 6 roots. So I am neglecting this first root when we put k equal to 0. Now let's start with the next value, that is k equal to 1. So that will become x equal to negative I cot 5 by 7. So that will become x1. Next root, that is x2. This is minus I cot 2 pi by 7. Next root, that is x3. This is minus I cot 3 pi by 7. So guys, if you see these three roots and if you compare it with our solution, then here when you put r as 1, 2, 3, here you will get I cot pi by 7, I cot 2 pi by 7, I cot 3 pi by 7 plus and minus. So out of that, the three negative roots are already covered. Now we have to bring remaining three positive roots. So I'll put k equal to 4. So that will become x4, which is negative I cot of 4 pi by 7. Now guys, let me tell you that 4 pi by 7 is not our root because the value of r is 1, 2 and 3. So I have to convert this 4 into 1, 2 or 3. Now let's do that. So therefore x4 is equal to negative I cot of, now that 4 pi by 7 we will represent it as pi minus 3 pi by 7. So you can see here that this will become 4 pi by 7. So let's find out its value. So this is cot of pi minus theta is minus cot theta. So that will become positive I cot of 3 pi by 7. Next, let's find out x5 and for that we will put k as 5. So that is minus I cot of 5 pi by 7. Let's convert this also. So minus I cot pi minus 2 pi by 7. So cot of pi minus theta is again minus cot theta. So this will become positive I cot of 2 pi by 7. And the last root, that is x6, is minus I cot of 6 pi by 7. So again this is minus I cot of pi minus pi by 7. So which is minus cot pi by 7, minus minus plus I cot pi by 7. So guys, here I got positive I cot pi by 7, cot 2 pi by 7, cot 3 pi by 7, and here we got three negative roots, and therefore we can say that the roots are plus or minus I cot of r pi by 7, where the value of r is 1, 2 and 3. And guys, here we have proved that the roots of this given equation as plus or minus I cot r pi by 7. So I'm sure that you like the explanation and you want to learn more such videos on complex number and engineering mathematics. So guys, don't worry, stay tuned with ekida.com, where you can find all my videos at one place and you can enjoy all videos in order. Thank you very much.